had to say that once.
Yeah.
Let's go ahead and get started. And if Keith is able to join us, we can catch him up. That's fine. Very interesting video. I have some questions. It was your first year designing the air brakes.
Yes.
Again, if you are Team 129 University of Sao Paulo,
Okay.
time has been moved to 1 p.m. Okay, and so I had a couple questions on the air brakes. It looks like the mount was 3D printed.
Yes.
What material did you use for the filament for 3D printing?
We used the
PETG across the board. All of our 3D prints are made with PETG this year.
Excellent, excellent. Right, and you have a estimated 10,100 foot apogee?
Yes.
Okay. Hot spotty tube. Onboard camera. What are you using for the camera? So I saw the shroud. What's the camera itself?
Lucas, could you answer that?
Yeah, so we're using Raspberry Pi cameras hooked up to Raspberry Pi Zeros.
Great. Cool. Have you been able to do any testing with the camera?
So yeah, we actually have experience from the previous competition with the flight, as well as we've done some basic testing this year with the cameras, as well as our communication systems, since we're centralizing data storage off the Raspberry Pis as well. We've tested that.
Okay, great. Yeah, it's so much fun when you can get video of that launch.
Yes.
And what kind of testing have you been able to do with the air brakes?
So unfortunately, this year we haven't had access to our university yet or purchasing from the university. So we haven't been able to get in and manufacture everything. We've only been able to do basic tests on certain things that people were able to make at home.
We do have control system tests though.
Okay, great.
So we've done some basic simulation tests with our control system at this point in Simulink.
Okay. And you have, so I think your motor, let's see. Is this yeah, you do. You've got 2 drogues, 2 mains. So you actually do separate. You separate after you're done igniting, right? After you're done.
Yeah, after motor
burn. Right. So post burn, you get about 2,000 more feet after deploying the first, after separation deploying the first. Is that just to get that extra height, to lose some mass, or?
So we fly in a boosted dart configuration to prepare in the future for a 2-stage rocket. It makes it more complex, but that's just something our team has done for the past few years to prepare for 2-stage.
Okay. So when do you think you guys would be moving to a 2-stage?
We're hoping that next year we can move to 2-stage and 30K.
Cool. Excellent. Okay, great. Great. And you have deployable fins?
Yes.
Can you tell me a little bit about how you selected the material and shape of those fins?
Barnabas, would you like to answer that?
Yep, absolutely. So material-wise, we selected the 6061 aluminum for both the bottom and top bulkheads, which house the deployable fins system, as well as the fins. This aluminum has high impact resistance and also is easy to manufacture, and it's affordable, which was also a concern with the purchasing problems this year. Regarding we also have this new feature that are T-bars in the deployable fin system that was made of 2024 aluminum, or will be rather 2024 aluminum that has very good stiffness to weight ratio and strength to weight ratio, which is good because that's what it's for, is to increase the stiffness of the deployable fin system. For, well, I guess the last major component is we had the pins that are made of tool steel. So they're good at resisting load.
Okay. And
Yes.
have you done aerodynamic analysis on the fins?
Yes, absolutely. We used COMSOL, and the aerodynamic analysis for the deployable fins was done together with the aerodynamic analysis for the air brakes system.
Okay. Okay. And how is that all controlled?
The deployable fins separate or fold out automatically upon separation, and the air brakes are controlled by a servo motor.
Okay. All right. This is hard being the only judge.
Yeah.
The space while I look at my notes. And then you've got your payload was, you had two elements to your payload. The studying the denaturization of the DNA and the I think the enzyme, something about the enzyme experiment.
Yes,
talk a little
Devin,
bit
would
about
you
that
like
one?
to?
Yeah,
you
no
can-
problem. Sorry, what was your question about that?
Oh, could you explain to me a little bit more about the enzyme, the enzyme part of the payload?
Yeah, no problem. Yeah, so it's basically we're taking chicken liver, it's suspended in hydrogen peroxide, and then we're going to measure, I guess, the pressure that outputs from that reaction, and it kind of measures the, the denaturization of the actual solution, and then we'll be able to compare that to the control that we had on ground testing. Once we're able to get back in the labs and everything, we're going to be able to see how those compare with in-flight compared to the ground testing.
And what is it about the launch or the altitude that you think is going to affect that, and how do you think it's going to affect that?
Well, our hypothesis is actually that it won't do very much, but we want to just make sure. And, with the rapid, I guess everyone's talking about, like, the presentation yesterday, I guess, about space flight and, commercialization of space flight. It's definitely an important thing that we got to, focus on.
Yeah,
and
you think the duration of that flight would be potentially enough to show?
well, even if we get higher apogee for next year, this is a good practice run, and then next year we can get even higher up, and definitely.
You think you'll use the same payload next year? Working towards.
I think it would be a good idea, but I mean, we haven't made a vote or anything like that yet.
So how far did you get on the manufacturing? It sounds like you mostly got component level. Are you going to be able to work further on the rocket this year? Or are you just going to start for 2022 at this point?
So our plan is that as soon as we are able to access our manufacturing labs and purchasing, we will build this rocket. I'm in the mindset where we're going to build this rocket no matter what, because we couldn't build our last rocket, and we need the manufacturing experience, and we need to test launch it. So we're going to build it either this summer or in the fall, depending on when we're allowed back in and allowed to purchase.
And you're still shooting for then working towards an advanced rocket for the next year?
Yes, yes. So we plan that if we are able to make this in the fall, we might be able to use it as a test vehicle as well for any new things that we're adding, so we can just make small adjustments to test things out.
Okay, great. Okay.
Sorry, actually, I don't think I answered all of your questions regarding the deployable fins. So regarding the shape selection, because somebody just messaged me that I forgot to talk about that. So regarding the shape selection, we wanted to have obviously as much stability as possible with the fins for the space constraint, because there is also that factor, right? Because the fins have to be able to be folded in the rocket. So we optimized that through Open Rocket. So with this configuration right now, the fins are as large as possible with the 5.17 inches sticking of fin height sticking out of the rocket.
Okay, excellent. Yeah, because I noticed, and again, I am no fin expert, but I noticed, you know, they're very rectangular, and I think that's what stood out to me was the shape was just very. I can understand how that's efficient for
Being folded up.
yeah, for storage. But you know, how does that affect it once it's out, right?
I'd also like to mention that this is a legacy project, so we have been making different iterations of this project for years now. We've just been improving on it, and we have used that rectangular shape in the past.
And flown it.
Yes.
Yeah, and that went well. That was
Yeah.
good.
Yeah.
Great. Okay, cool. Excellent. I think that's all I have on the notes. Is there anything else that you would like me to know about your project before we move on?
Is there anything you guys would like to mention about your projects that you weren't able to mention in the poster session?
I think I'm good. I covered it.
I just want to say, Hannah, I love your picture.
I guess if no mechanical member has anything to say, I'll plug the electrical team.
Yeah.
I'm the electrical team lead. I know that the primary focus on everything is mechanical, but we've done quite a lot of work on our electrical system. We've created just about everything from the ground up. We had a couple slides in the poster session about this. So we've got all of our data recording boards for our 2 experiments. We've got wireless communication within the rocket to our air brake motor controller. And we've also got a long-range communication down to ground. That's all been done in-house, fully designed and routed, and is ready for purchasing that we've all completed this year.
And the mounting boards for all your electrical, all the housing, what is that? Is that also PETG or is that?
Yes.
Okay. Yeah. Okay, cool.
And I can plug a little bit more in about the electrical stuff too. I do most of the software development for the rocket as well. And we are we started everything from scratch as well on the software. We're trying to develop a driven software system. So we're using a publisher subscriber model for all of the data transfer on the rocket, a message-based system similar to Car Automotive Network. So we're doing every board, like the ones that Justin just mentioned, send messages onto an Ethernet link between the computers, much like the LAN network in your home or Wi-Fi. And then we're going to be doing event-based messages around it, carrying the signal data, which is then going to be used completely in a publisher subscriber model for data transfer, so we can have a safe experience. So we have no memory leaks in our software, so we don't have to worry about we sat on the launch pad for 30 minutes and then we've realized we've used all of our memory, we launch and something crashes. So we're trying to really care about the fact that our software might kill our rocket if we make some issues in that department.
Yeah, there's always launch delays, right?
Yeah, so we're being very cautious about that with the electrical power drain, as well as on our software memory management, and also like our data storage. We have lots of room as well as triggers to make sure that all works well.
Great. Great, that sounds good. I think that is time. Thank you so much. I appreciate all of your hard work